Hello friends, welcome to our channel. Now we are going to see binary search. Let us consider the problem of finding a word in a dictionary. Typically, we directly go to some approximate page, say middle page. If the word is found in the middle page, then the search is complete, isn't it? If the word seems to be in the first half, we apply the same process to the first half. Otherwise, we apply the same process for the second half. Binary search also works in the same way. For a given list of elements, if the key is found to be in the first half, then we work on the first half. Otherwise, we work on the second half. This process will continue. What we have to notice here is, every time we are going to divide the problem into two parts and going to work on the one part based on our requirement. Nothing but divide and conquer. Every time we are going to break the problem into smaller units and working on these units. Let us consider an example. Now let us search for the key 8. We have these elements. All these numbers must be in sorted order. Initially, low is pointing to 8, mid is pointing to 42, high is pointing to 85. Notice that 8 is less than 42. So, we need to consider the first part. So, the second half is untouched. Now, low is 8, mid is 20, high is 42. Again, key is less than mid. So, we need to consider the first half. We have 8 and 20. Now, low is equal to mid is equal to key. Thus, we find the position of the key. That is the first position. Similarly, we are going to search for the key 56. Initially, low is pointing to 8, mid is pointing to 42, high is pointing to 85. Here key is greater than mid, that is 56 is greater than 42. So we need to consider the second part. Now, low is pointing to 56, mid is pointing to 67 and high is pointing to 85. Here key is less than mid, so we need to consider the first part. Now, low is equal to mid is equal to key. That is, we got our key and the position of the key is nothing but the value of the mid. Now, let's look into the algorithm. Initially, the value of low is 0, high is number of elements -1, key is nothing but the value we are going to search. This while loop is going to execute from low to high. Here we are computing the mid value, which is nothing but low plus high by 2. Here we are checking whether key is greater than the middle element. So this is the case. In this case, what we are doing, low is updated to mid plus 1. So in this case, key is less than the middle element. So we are updating high to mid -1. If key is neither greater nor lesser than the middle element, then what does it mean? Key is equal to the middle element. So, we are returning the value of the mid. Now, let us see the time complexity of the algorithm. If the input array is already sorted, then in the best case, we need constant time, which is nothing but the element we want to search is exactly in the middle of the list. So, we need not do much work. So, let us consider this worst case time complexity. In the worst case, the element, which is nothing but the key, is located at the extreme positions of the list. In such cases, we have to break the problem into many units. So these cases are considered as the worst cases. In this worst case, we take O of log n time. If the input array is not in a sorted order, then we have to sort the array ourselves. So it takes O of n log n time.